All right. So we started yesterday, lesson 16, but we'll just kind of run through here real quick. Just remember, this is super important for our test. I mean, I shouldn't say that. I mean, just in general. Just in general. Not necessarily for the test, just in general. Again, metals are easily deformed because they have those sliding layers with electrons and all that, so they slide out of the way. They usually dent, metals dent. Ionic compounds will usually break in a smooth plane, yes. Like charges line up and repel each other, positive, negative, positive, positive, negative, negative, positive, positive, and they tend to repel each other. They break in a smooth plane, and of course, molecular compounds are pretty weak in comparison. They're pretty soft. Okay, examples of that would be like things like sugar. If you hammered on sugar, okay, it really pulverizes it, kind of. And candle wax would be another example there, where it kind of, the hammer would probably sink into it a little bit, or at least, you know, kind of pulverize that a little bit as well. Okay. So those are three things. Those are three things you could do. You could, you know, if you're not sure of a compound, you could check out how well, you know, what does it look like when you hit it, right? Because you're going to get three different options there. Okay. Do I need to do the desk again? I see some people are on their cell phones, not naming names or anything, but I just wake you up a little bit. Desk. It's good. Eventually, one of these days, it's actually going to dent, and then that's what you know. Anyway, I've weakened it over the last couple of years, I think. All right. Conductivity is another great way to do this. Okay, and we talked about this yesterday. Metals are good conductors of electricity in solid form, in liquid form. Okay, whatever you need to write down here, just make sure you know this. Metals are great conductors of electricity. Metals are always good conductors of electricity. Ionic compounds, we kind of went with this thing here. If we talk about ionic compounds, I said this, and I don't know if I wrote this down really well yesterday or not, but in solid form, if you had an ionic compound in solid form, okay, they should not be conductive. They should not be conductive. They might, but it would be very, very, very little, okay? They might, but it's very, very little. In liquid form, so if you melted that, not only would you find out the melting point of this compound, but you'd also find out that it becomes a very, very good conductor, okay? It's a very good conductor in liquid form. Liquid salt, for example, is a very good conductor, okay? Most of us would never know what that looks like because you would need like about 800 Celsius to melt it, okay? So I doubt most of us have melted salt, okay? In water, that's H2O, you get two options. So if you put the ionic compound into water, all right, then you kind of get two options. Now, I wrote this down the other day, but I don't think, actually I used very good, because I think I talked about solids and aqueous and stuff like that. What I should have probably put is, and again, this is not something we need to worry about too much, but if it's very soluble, it will be very good, okay? Again, it kind of depends on how much you put in, okay? If you just put in like 1 grain of salt, it's probably going to be a little bit conductive. If you dump in a whole jar of salt and stir it up and get it all to dissolve, then it's probably going to be very good, okay, because it's going to have a lot of free ions. Water breaks that apart. If it's slightly soluble, it would be a poor conductor. Again, with a little bit of, you know, give and take there. So it's still going to conduct. That's the important part there. Okay. So they always conduct, but to different degrees. Okay. I would really focus on these two here probably. That's kind of important. We didn't really talk too much about this because that's kind of a little bit more Unit 3 stuff, but we will eventually. Okay. Very good conductors or poor conductors. All right. Now, good? Yes? Last thing I'm going to say is this. I think that's it for that. And we're going to skip to, no. That's what, you guys remember what the conductivity testers look like, right? They got the battery on the top, that 9-volt that you put on the top, and then you push the button on the side and lights up 1 to 10. It's got the 2 little prongs, right? We went to the lab and did that last year with the properties of compounds thing in Science 10. Okay, so that's kind of just a version there. But again, if it's not a compound, it'd be very good. Okay, molecular. What's underneath here? Oh yeah, we just skipped all. Don't worry about that. Molecular compounds. This you're gonna have to write down. This is new. Molecular compounds do not conduct electricity, ever. Never ever. Okay. So I'll let you copy that. Okay, so the key here is this. Okay, first of all, molecular compounds do not conduct electrical current ever. Okay, solid form, no. Liquid form, no. Put a molecular compound into water, no. Okay, should not conduct ever. Nothing in no way, shape, or form should not conduct electricity. Okay, good. Never. So that's a pretty big difference between the other ones, right? Right. So make sure we know that. Make sure you know those things that we talked about here. They're really important. Okay. Good. All right. Now, another 14 slides to go, and then we're done. Okay. Here we go. Oh, wait. Not true. I'm thinking. What? Thursday? No. What's today? Today's the 6th, so 7, 8. 8th is Thursday. What do you mean no? You're not going to study anyway, are you? Next Wednesday? Okay. I was going to say Thursday, but we'll do Wednesday. Thursday. Nobody needs to. So we'll have a test on Thursday, October 15th. One test. I'm going to give you some stuff to review. Yes. Great question. You will have, I guess we can talk about that right now. I'm going to ballpark. All your tests are going to be pretty similar, but they're going to be about, I don't know. Let's go in this range here. Good old 20, 25 multiple choice. Hopefully it's not multiple guess. Okay, we don't want that. Multiple choice, so pick one. Then we're going to have some on this one. Oh, yes, we are going to have some, I don't know, I'm going to say somewhere in here about 5 to 10 numerical response. So you're going to write down some numbers for me. Okay, whatever that might be. We'll maybe talk about a little bit about that. Could be like a little matching thing, for example, even like, so some definitions with 4 options. Could be names of the shapes, 4 options kind of thing, match them up to the shapes. Could be bond angles stuff. It could be lots of stuff. Okay, so kind of a little, I guess you could say a little bit of matching in some cases, probably, because we don't have any like calculations to do or anything like that. Or anything like that. So about 5 to 10 numerical response. And then we're going to have, I believe, I want to say about 4 written response. Which could be anything from drawings. So maybe a drawing kind of thing. So just show me what this diagram looks like. We might have to justify which one has a higher melting boiling point. We might have to talk about which compound are we talking about here with these set of conditions, things like that. Okay, so 4 written response. I'm just going to tell you the questions I'm going to give you are kind of similar to, well, in a way, they're similar to what you're going to be expected to know. So if you can do the review questions, we probably should be okay for those. Okay, and we'll go through those. Yep. You can do whatever you want. Big shocker. No one cares, eh? It's just teacher. Whatever. All right. Okay, so that's kind of what we're looking at for the test. Good? I'm going to give you some questions today. And it's going to ask, and same on the test. You're going to have these questions at some point. I'm going to give you a list of molecules, maybe 4. Ooh, 4. And then we could organize them from lowest to highest melting points or boiling points, perhaps. Can you say numerical response? But I'm going to give you some compounds. We're going to get a little practice with this today. I'm going to give you some compounds. How do we decide which ones are the strongest, which ones are the weakest? What do we do? What do we do? You tell me. What? Could draw them, that's never a bad idea to draw them out. If you're ever not sure and I give you some molecules, you might want to draw them out to make sure you know what's going on. But ultimately, find the force that links them together, yes? Is it ionic? Is it metallic, right? You remember this one from yesterday, yes? Where do these molecules fit? And I don't know if you obviously figured this out or not. We don't know which one's stronger, metallic or ionic, yes? So I'm not going to give you one of each of those because then you wouldn't know, basically. I shouldn't say that. But true, yes? And then you could also go to molecular. And if you got molecular, is it hydrogen bonding? Is it dipole-dipole? Is it London? And then do we need to talk about size and shape maybe as well, right? At the end here, is it, does it actually come down to size and shape? Because it will at some point, perhaps, okay? So we use this to compare strengths, right? The better they stick together, the farther up this chart you are, or whatever you want to call this, the stronger they are, yes? The higher the melting boiling points have to be, okay? We have to know that, yes? Hopefully we do. Hello, is this thing on? Okay, I have a microphone so it works well. All right, so we're going to use this to help us decide which one's stronger, or if we had 4 of them, which one's the strongest? What's the next strongest one? What's the next strongest? Which one's the weakest? Yes, or vice versa, weakest to strongest, whatever, okay? Those kinds of things, yes? Okay, does that make sense? Okay, so I'm going to give you some questions today that are going to help you with that. And then I have some more questions for review as well, because you got a whole 4 days off. So I'm going to give lots of questions to practice here. And we're going to go over those eventually here as well. But we need to take a look at that, okay? All right, so I wanted to mention that. I think that's what I wanted to mention. So if you ever ask to compare molecules, we use this, okay? Whether it's 2, like you're going to get in your homework today, or 4, okay? It doesn't matter, or 20. That'd be tough, but, we'd basically do this kind of thing, okay? If it's ionic or metallic, if one of those compounds is ionic or a metal, right? Like when I say metallic, I'm talking about like things like maybe, if it says iron, that's a metal, that's metal, right? How does one iron link to another iron atom? Well, it's metallic bonding, right? Positive ions, negative electrons, yes? So just keep that in mind, yeah? Or ionic, of course, and molecular would be down there. We have to maybe draw them out so you know which one's which. And, again, this comes down to this. Don't get caught with this. What kind of bonding is in pH2F? If you think about that, some of you guys already know what that looks like. Well, what kind of bonding would you have there? Well, I guess first thing, this is exactly what I would do. Grab a compound and start putting them into, is it ionic? Yes or no? Is that an ionic compound? Yes or no? No. It's a metallic. Is it the metal atom? No. Is it molecular? Okay, we got non-metals here, yes? If you don't know this, we're in trouble. Sorry. I don't know how else to say that nicely. Is it hydrogen bonding? Yes or no? Well, you better draw it. You better know, because you can't afford to mess that up, right? It is not. Is the H bonded to the F? No. H is bonded to P in this case, yes? So we'd say dipole-dipole because it's polar, yes? There's a lone pair on top of the central atom. So you go with that, correct? Okay. So again, you just kind of slot them in. And if the other compound that you're comparing is down here at London, well, this one's stronger, yes? So we're going to go with dipole-dipole, right? That's what you're going to do. Okay, good? All right, actually record this. So again, chapter 2 here, we've done, just help me out here again. I think we did what? 4, 5, 7, and 12. Okay, so those are the ones we've done hopefully by now. I'm not going to check today because I just want you guys to work. So we need to go back and do this one. 6. We're going to go back and do that now. Okay. 7, 11, 12. Okay. And now here we're going to get into 13. And 13 basically says exactly what we just finished talking about, which one has the higher boiling point. So as long as you don't have to give me a long explanation, you know, draw the 2 out or whatever, pick one, just write it down, but just quickly tell me, why is this one stronger? Is it hydrogen bonding compared to dipole-dipole? Well, what's the force that's going on there? So we're going to do 13. We're not going to do all these. 13A, C, E I like. We're going to do G. We'll just see. Oh, definitely I like that one. N and O and R, definitely like that one a lot, and S should be good, and T. I'll give you that one because that's a nice easy one. Okay, all right, so we're going to do those. Very important, numero 15 we're doing. Okay, 15. I never did show you this. Just please write that down just so I know. You can remind me. We got to go to the lab about do that one. 16. And then we're going to do, I don't know, I think 24 is probably good. Okay. And that's good for that. Okay. All right. I'll let you work on those. If you don't have the first ones done, well, I guess you better get those done too. Okay. We should, but in case you don't, get those done.